All right, so as always, when we're predicting the product of a reaction, the first step is that we have to decide what type of reaction we're dealing with. Okay. The second thing is that we kind of figure out who goes with who. Then we check for special elements and drop and swap ionic compounds. And then lastly, we balance the whole reaction. Okay, those are the set of steps that we're always going to go through. So for question number 1, I have an ionic compound in calcium oxide reacting with an element in sulfur. All right, what kind of reaction has an ionic compound reacting with an element? Single replacement reaction. Okay, so in a single replacement reaction, the single has to replace the part of the ionic compound that it is like. Okay, since sulfur is a nonmetal, it is going to be replacing what part of calcium oxide? The oxygen. Okay, it's going to switch places with the oxygen. That way I get an element and a new ionic compound. So I'm going to have calcium sulfide and I'm going to have oxygen. All right, now the next thing, now that I've decided who goes with who, is I have to check for special elements. Do I have any? Yes, oxygen is a special element. It's O2. We'll say 1 mark for that. Okay, they have to have O2 though. Okay, and then I have to drop and swap the ionic compound that I have here. Sulfur's a -2, calcium's a +2, so that compound is fine the way I've written it. We'll say that could be a mark 2. Okay, so they get 1 mark for each product. Now we need to balance the whole reaction. Our general rule for all reactions not combustion, okay, is that we start with the biggest number. 8's our biggest number, so I'm going to go over to the product side and make sure my sulfurs are balanced by putting an 8 in front of calcium sulfide. That gives me 8 calciums, so I'm going to go back over to the reactant side and balance my calciums with an 8. When I do that, it gives me 8 oxygens, so I need to come back over here and put a 4 in front of the O2 so that I have 8 oxygens on both sides. Now the whole reaction is balanced, and that will be my third and final mark for that. Okay. Questions on number 1? All right. Question number 2. Okay, we've got C10H22 reacting with oxygen. What kind of reaction are we looking at here? It's a combustion reaction. All right, in a combustion reaction, our products are always the same. Those products are carbon dioxide and water. 1 mark for water, 1 mark for carbon dioxide. Okay, we have special balancing rules for combustion reactions. We have that we have to balance alphabetically, and we have the rule of 2. And the rule of 2 will apply here because 10 is an even number. I'm going to put a 2 there. All right. Now I'm going to balance alphabetically. 2 times 10 is 20, so I need to put a 20 here in front of my carbon dioxide. 2 times 22 is 44, so I need to put a 22 here. So I have 44 hydrogens on both sides. Now I need to figure out how many oxygens I have. So I've got 40 oxygens here in the carbon dioxide, plus another 22 is 62 oxygens, which means I need 31 over here. All right, so if they have 2, 31, 20, 22 for their balancing numbers, then they can have that third and final mark. Questions on number 2? Okay. Question number 3. I have iron 3 hydroxide reacting with sodium phosphate. Both are ionic compounds, so this is going to be what kind of a reaction? It is a double replacement. In a double replacement reaction, all we do is create 2 new ionic compounds by swapping the metals to give them new partners. All right, so that means that we will have sodium with hydroxide and iron with phosphate. Now I need to drop and swap the 2 ionic compounds that I've made here. Okay. Hydroxide's a -1 and sodium's a +1, so sodium hydroxide is fine the way I have it written there. Okay, phosphate is a -3, and this iron over here is a 2 or a 3. It's 3. It's the iron with the 3+ charge. Okay, I figured that out by knowing that hydroxide's a -1. All right, so then that means that this compound is also fine the way I've written it because it's -3 and +3. Okay, so it's good that way as well. So you can give them a mark for NaOH, and you can give them a mark for FePO4. They don't have to have the compounds, they don't have to have sodium hydroxide first. If they have sodium hydroxide second and FePO4 first, that's fine. There's no, doesn't matter on the order, okay? As long as they are Na first, OH second, okay, and Fe first and PO4 second. Everyone follow me there? All right. Now we have to balance the whole reaction. I would say probably best to start with sodium. It's the biggest number. Okay, there's 3 on this side, so I'm going to make sure I have 3 over there. Okay, that gives me 3 hydroxides, and I have 3 over here on the reactant side. I have 1 iron, 1 phosphate, 1 phosphate. I only needed that one number. Okay, so if their balancing looks like that one, they can have their third and final mark. Questions on number 3? All right. Question number 4, I have phosphorus reacting with nickel. What kind of reaction is that? It's a synthesis reaction. They're both elements. But did I play a trick on you? Oh, burned you. Some of you. Okay. What kind of compound am I going to make here? Ionic. What do you write first in an ionic compound? Metal. Okay. I told you that twice. That I don't have very many tricks. Okay. So if I spoil one for you, remember it because I'm going to use it later. Okay. So this is going to make an ionic compound. So if they have just an ion, like here's how we'll do this. They got NiP, Ni first, they can have a mark because this only has one product. So we have to figure out how to make 3 marks here. Okay. So if they have it in the right order, we'll give them 1 mark. Okay. And then I have to drop and swap this. Phosphorus is a -3. And what's the most common charge for nickel? +2. Okay, they don't tell us which one this is, so we have to go with the most common charge. So we got +2, so we're going to have Ni3P2. All right, so if they've got those 2 numbers, even if they have it in the wrong order, we'll call that their second mark. They dropped and swapped it correctly. Now we have to balance the reaction. I would say that it's probably best to balance our phosphorus first because it's the biggest number. So I'm going to put a 2 here to give me my 4 phosphorus, which gives me 6 nickel. Okay. So if they've got that for their balancing numbers, they can have their third and final mark for that one. Okay, and for number 5, I only have 1 reactant. So this has to be what kind of reaction? Decomposition. All right, so this thing is going to break down into nitrogen and hydrogen. Now we said with decomposition reactions, we always have to be on the lookout for special elements because we're going to get some formed for sure, okay? Like these 2. All right, so 1 mark for N2, 1 mark for H2. Okay, I would say we should, actually it doesn't matter which one we balance first. Okay, I'm just going to balance the hydrogens first. I'm going to put a 2 here to give me 6. Okay, I'm going to put a 3 here to give me 6, and that makes my nitrogens balance at the same time. Okay, so 3 marks for that one. Whole thing's out of 15 marks. So please give them a mark out of 15, and then I'll have them in a nice, neat pile right here, please. When you come up and hand them in, grab a Chromebook.